Hello, this is video 2 for AP topic number 8 in AP Physics 1. So, in the first video we talked about charges and what the fundamental or elementary charge was. Now this video, the goal is to explore what happens when you have two charges that interact with each other. And the law that governs interaction of charged objects is called Coulomb's law. Now that should sound familiar from the last video. The unit for charge is measured in coulombs, and this law is also named after the same person. And so this is how it's written on your reference sheet. We have the force, it's got an arrow over it. That's because this is a vector quantity. It does have a direction. And then you'll see the E, and that just stands for the electric force. Okay. Then there's this value K, that is a fundamental constant. This is called Coulomb's constant. And once again, you don't have to memorize this. It is on the back of your reference sheet. It says Coulomb's law constant, and it's available. You never have to memorize it, but we'll use it a bit, so it should become familiar to you. And then we've got these two Q values. These Q's are the charges. Okay, these are our charge values. So notice we have two of them because this law governs the interaction between two charge values. And then R is the distance between those values, between those charges. It's called the radius, but it really is between whatever two objects of charge that you have. And then we squared this value. Now, if you're thinking that this might look familiar, I hope that you do see this. It should look like another force law that we had. So if you're thinking, hey, that's kind of like the force of gravity, you'd be right, where we have a constant, two values, and then the radius squared. Both of these follow a very similar pattern. The biggest difference, though, is gravity only ever attracts. Masses can only ever attract to each other. But charges, because we have two types of charge, positive and negative, the electric force can either be attractive or repulsive. And so that's why you see these absolute value marks around these quantities. That's because you're in charge of determining if, after reading the question, are these charges attractive or repulsive? If you have two positives, that's going to be a repulsive. If you have one of each, that's attractive. But you have to determine that. And based on the geometry of your situation, you'll have to determine the direction of this force. But it does have a direction. It is a vector. Okay. In this video, I'm not going to go too deep into the direction of the force. I just want to give two basic practice problems to really get yourself familiar with just the foundation of this question, or foundation of this law. So the first one is this. I'll take a moment to read it. 2 points of equal charge produce an electric force on each other with 3.4 times 10 to the negative 2 newtons when placed 10 centimeters apart. What is the charge on each? Okay, so that's the basic question. Our formula, Q's. I got myself mixed up with gravity. Okay, so since we're looking for the charge on each, we're solving for Q. So I'm going to rearrange this. And so I should get the electric force times the radius squared over K. That K is that Coulomb's constant. And I should be able to plug all of this in. So this is 3.4 times 10 to the negative 2 newtons times the radius. Now, they did give us the radius, but warning, it's in centimeters. We need this to be in meters in order for this law to work. So we're just going to do quick conversion, 0.1 meters. And then we're going to divide it. Oh, careful, I almost forgot. We have to square that radius. That is actually a very common thing for people to forget. As you saw, I almost did it too. And then we're going to divide by Coulomb's constant. This is just 9 times 10 to the 9th with a big unit behind it. And so that's the So that's Coulomb's constant. Okay. I leave that to you as an exercise to simplify in your calculator, because what I'm more interested in is how do we get the charge of just one object? We have Q times Q, which, if you remember from your math class, is the same thing as Q squared. So when you simplify this, the next step for you to do is to take the square root. So we're going to take the square root of this number. And so the square root of Q squared is just Q. So this will be the charge of just one of the objects. Okay? And so final answer, assuming you've plugged everything else into the calculator correctly, is 1.94 times 10 to the negative 7th coulombs. Okay, so this is the charge on each object. If you're not sure, you could take this and plug it back in, and you'd find that you'd still get the same force outwards. Now, they didn't tell us anything in the question about attraction or repulsion, so I can't really tell you if this is a positive charge or a negative charge. All I can tell you is the exact amount of charge that's on each of these objects. And so just keep that in mind. We'll get into more advanced problems, but this is just a basic to get yourself familiar with the formula. Okay, one more example, a different kind of example. So in this question, two charges produce a force on each other of 4.5 times 10 to the negative 3 newtons. What is the force between them if the charge on each triples and the distance between them doubles? That is kind of different. We're only given one number, but we can actually still do this problem. Even without knowing what the exact charge is or without the exact distance, we can do this. And it all comes down to proportions. So once again, the basic equation, Coulomb's constant, Q1, Q2, over the distance between them squared. If we just think about this just a little bit, if the charge on them triples, that means it's going to increase. That means this top has to get bigger. Well, if the top gets bigger, that means the force is going to get bigger as well. And then the distance between them doubles. Okay, so that means the R value is going to get bigger, but it's in the denominator. So if the denominator gets bigger, then the force should get smaller. Okay, so which one's going to win? The bigger force with the bigger charge, or the smaller force with the bigger distance? Well, that's what we're essentially going to try to find with this question. And so this is how I personally approach this question. So I look at the basic setup. I pretty much ignore the K. It's a constant. It doesn't really matter. So I have 3Q and 3Q because each of them triples. The charge on each triples, so I need 3 and 3. And then it says the distance doubles. So I'm going to do 2R, but don't forget that whole thing gets squared. And so then I look and I say, okay, well, how can I take those numbers I just added and sort of remove them from the base formula? So what I mean by that is like, well, I've got 3 here and 3 here, so on the top, I should have a value of 9. Then I have my K, Q, Q. But on the bottom, this is 2R squared, so we're going to have the R squared there, but 2 squared is 4. So that means when I applied these conditions, I got 9/4 times my original force value. So this original is just what they gave me. The original gives me 4.5 times 10 to the negative 3rd newtons. Now I'm going to multiply that by 9/4. So if I multiply that by 9/4, I should get my new force with these conditions applied. And so if you take a moment and plug that into your calculator, you should get 1 times 10 to the negative 2 newtons. For those of you who aren't too familiar with scientific notation, this is a unit where you're going to want to use it. Be very careful with your parentheses, and it should be pretty straightforward with your handy-dandy calculator. Okay, so this is an introduction to Coulomb's law. Once again, just very basic questions to get you familiar. I will say this second question is very common with multiple choice questions. Instead of having you find the new force, a lot of times they'll just ask you what the factor is. And so if this was a multiple choice question and said, what factor does the force change? The answer would be 9/4. Very common multiple choice question, just wanted you to be aware. Look forward to more complex questions and questions where we start really dealing with the direction that comes with the interactions between two or more charged objects.